Hello everyone. In this example, we are going to use chain rule to compute the derivative of a function that is dependent on x and y in turn each depend on t. So you can think of t as time, something like that. Okay, so we've got a function u equals e to the power 2x sine 7y, and x is t to the power 9 and y is pi t. Okay, so I will usually represent this stuff using a diagram, which has helped a lot of people to figure out what to do, right? How do we take the derivative? So remember this. So start at the top with u, which is with your original function. Then u depends on x and y. So you're gonna put x here, y here. And then x itself depends on t, and y also depends on t. Once you draw this diagram, you want to fill out the partial derivatives or the derivatives, depending on whether it's a two variable situation or just one. Well, u depends on two variables, so it'll be a partial. So this will be partial derivative of u with respect to x, right? So you just take the top variable and x. Now on the other side, it's going to be partial derivative of u with respect to y. And then over here, we want the derivative of x with respect to t. But because x depends on only one variable, this will be a regular derivative. So it's not going to be that partial symbol. It's just going to be a regular dx dt. And then over here, it would be dy divided by dt. So how do I find the derivative of u with respect to t? So I just follow the tree, okay? So whatever gets me to t, I multiply. So I'll get du with respect to x multiplied by derivative of x with respect to t. Okay, so that's part of the chain rule. And then plus derivative of u with respect to y. So now we're traveling through the other side of the tree, but we're still getting to t, right? And then multiply that by dy over dt. Okay, so let's think about if we can fill out all the pieces. First, what is the derivative of u with respect to x? So first of all, these two things are multiplied, right? Now, when you take in the derivative with respect to x, the other term, you treat it as a number because the other term has no x. So even though it's some fancy sine 7y, whatever, but it's just a number. So this is a number. And we have a rule with derivatives called constant multiple rule, where we just keep the number. We don't get rid of it. If it was added or subtracted, you would get rid of it. But because it's multiplied, you keep it. And you are just taking the derivative of this remaining term using the regular chain rule, which is just 2e to the 2x. So hopefully everybody knows that derivative of e to the ax is a e to the ax. So this will be 2e to the 2x. And then the other one you keep. So this will be 2e to the 2x sine 7y. Okay, now let's try to take the derivative of it with respect to y. If we're doing with respect to y now, e to the 2x is a number. Okay, so like this part right here is now a number. It's fixed and it's a constant multiple. We keep it. And so now what about derivative of sine of 7y? So derivative of sine is cosine, but is it going to be 7y or is it just going to be y? It's going to be 7y. So it's going to be cosine 7y, and then 7 goes to the front. That's a regular chain rule. Okay, so and then the other term we keep. So we're going to get 7, and then we do e to the 2x, and then this cosine 7y. It's customary to put the numbers in the front. So I'm just kind of reordering it by putting the 7 to the front. Okay, now how about derivative of x with respect to t? Well, that's just a regular derivative. So that's just power rule. So 9t to the power 8. Okay, how about derivative of pi t? So pi is a number, even though it's a fancy number, 3.14, whatever, it's still a number. So number t is just a number. So that's pi. Okay, so we got that part. Now we want to use the chain rule. So what does the chain rule do? So I'm literally substituting all the pieces. First, I take the derivative with respect to x. So I got 2 e to the power 2x sine 7y. And I multiply that by dx over dt, which I got, which is 9t to the 8th. Okay, then plus, then derivative with respect to y. So I got 7 e to the 2x cosine 7y, and multiply that by dy over dt, which is pi. Okay, so if that was it, that, we will be done. But we're not done because we do have a mix. Like we have x and y and also t. We want the final answer to only have t. So what are we going to do? So what you're going to do, unless your teacher wants you to simplify. If your teacher says you don't have to simplify, then you don't. So everywhere where you see x, you change it to t to the 9. So I see it here. I see it here. And I'm going to change it to t to the power 9. And I'm not going to do anything else. Okay, and then everywhere where I see y, so again, unless I need to simplify, and hopefully just pray that the teacher does not ask you to do that, you just replace it in here. Oops, right here. Okay, all right. So if you keep it straight, then it'll work out. Okay, so we get e to the power 2. Instead of x, we put t to the power 9. So it's like a power to the power, huh? Okay, then we have sine 7, and instead of y, we put pi t. Okay, multiply that by 9t to the power 8. Okay, got that. Plus 7 e to the power 2 again. Instead of x, we put 2t to the power 9. Replace that, and then we get cosine 7y, and y is pi t. And then we multiply that by pi. Okay, let's hold our breath and hope that that's right. Yay!